Okay, I made a paper for the Year 12 AS class I teach using a lot of questions from the January 2020 papers, and they just finished their electricity section of the syllabus. So the biggest part of this will be electricity. Yeah, there is some SUVAT from mechanics because we've done some practical skills, including the first 3 core practicals. Okay, so I've cut down the paper to 38 marks, and because it's their first proper A-level test, we're going to use 50 minutes of a lesson to get these 38 marks done. Okay, so I've kind of made it like a linear exam with 3 sections. Section A, multiple choice, yeah. Section B, structured questions, and Section C, applications of physics, which is very similar to the linear exam. So to start with, there's an intro to physics section, which is focused on units. And question 1 reads as follows: which of the following quantities has the SI units equal to kilograms meters squared seconds to the minus 1? So that's what you've got to do. The method I've put here for you, you've got to have an equation which defines the term, and then you enter all the base units, and then you simplify it. So force is mass times acceleration, that's the definition. So once you've got the definition with an equation, mass is kilograms, acceleration is meters per second squared, so it doesn't equal this. So the first one is definitely wrong. Second one is momentum, which is mass times velocity. Mass times velocity is kilograms times meters per second, which again, these 2 are wrong. Number 3 is power. Power can be force times distance over time, yes, which is work done over time, which is the same as force times velocity. And since we know force from A is kilograms meters per second squared, multiply that by velocity. This is looking more promising. Your simplification, step 3, is kilograms meters squared, because there's a meter here and a meter there, and seconds to the power of minus 3. And this is the same as what we're looking for. So for the sake of completion, let's do D. D is work done, which is force times distance. Force times distance means kilograms per meters seconds to the minus 2, yeah, multiplied by m, I forgot to do that, and that will give you kilograms meters squared seconds to the minus 2. So the power of seconds is wrong, so the answer is C. So that's how you do these units. Define the term, enter all the base units you got, and then simplify. Question 2 is also on units, and it wants you to find out which of the statements that are in A, B, C, or D describes gravitational field strength. So once again, you need to know what gravitational field strength is. That's G, which is newtons per kilogram, which is the same as meters seconds to the minus 2. Yeah? So you can see force per unit length would be newtons per meter. So that's not the same as G. Force per unit mass is the correct answer because it's newtons per kilogram. So that is equal to what we're looking for. And potential energy is joules per unit length, joules per meter. So this one we know is also wrong. And potential energy per unit mass is joules per kilogram. Yeah, which is actually gravitational potential, which you meet in year 13. That's a year 13 quantity, but you can still work it out based on the words, what the definition, and therefore the units will be. So that's 2 questions, intro to physics. And there you see the answers were C and B, and these were taken from Unit 1 of the International A-Level paper from January 2020. Okay, so then I took some more multiple choice questions from a different International A-Level paper, yes, and the first 2 are on waves, so you can try and look at them if you want, but it's not counted in this test. So I'm going to go straight to the electricity questions, where you've got a table showing series and parallel values of resistors. So it says the table shows the total resistance, RT, yeah, if two 5-ohm resistors are connected, first in series and then in parallel. Well, series, we know they're just simply, you just need to add the two together, yes? So these two is from that rule. And in a parallel circuit, if they're both 5 ohms, the answer will be half of that, because the total resistance in parallel is always less than the individual resistors. That's what I'm saying here. So listen to what my audio rather than looking at what I've typed on its own, because you might think that's R1 divided by R2. Here, what I'm saying is, in parallel, the total resistance will be less than R1 and less than R2. Okay, so it cannot be 10 ohms, so you don't even need to calculate it. We just know it has to be 2.5 because it cannot be 10 ohms. Okay, so the answer is therefore D. Question 4 is about an ideal diode. Yes, there's the voltage current characteristics, yeah, which we spent quite a lot of time on in the course on electricity. So they got 3 points of the graph, X here, Y here, and Z here at the peak of the current, okay? At which points is the resistance of this diode infinite? Well, if the resistance is infinite, yes, then the current will be 0, yes? So which 2 points is the current 0? The answer is X and Y, so the answer has to be A, X and Y. Okay, so the answer is A. And you don't need to look at the others. If it's not 0, it means the resistance isn't infinite. If there's any current, it means the resistance must be below infinity, okay, whatever its value will be. Question 5 is a copper wire that has a cross-sectional area given here. And the current is 0.93 amps. And it has an N value, conduction electrons per meter cubed, of 8.4 times 10 to the 28. So that's N. So basically we're looking at this equation, the transport equation as it's sometimes called. I equals NAVE, where E is the charge for an electron, because the electrons are the charge carriers in a copper wire. Which of the following numbers combination gives the magnitude of drift velocity? In other words, we've been given I, we've been given N, we've been given A, and we know that the data sheet will tell you that the charge of an electron is 1.6 times 10 to the minus 19 coulombs. Negative, of course, but over here it doesn't really matter about the size, the sign of the charge. So if you write the equation with V as a subject, you'll see that V will equal to I over NAE. So we want I on the top. So only two of them have I on the top. Yeah, A and D. So it has to be A or D. And then you can see you need 3 terms on the bottom, N, A, and E. And you can see this one's got E missing. So the answer should be D. There's N, there's A, and there's E. So the answer is D. Okay? Question 6 is another waves topic. Yeah, but for those of you who were talking to me about photons, yeah, this might be interesting for you to read. I'm not saying I shouldn't really do that. I'm not saying the B is the answer. I'm just saying that it might be. I haven't really read it in detail. Increasing the frequency of light increases the energy, and therefore it looks like B would be the answer, but I haven't read the question. E equals HF. So in other words, just like on the electromagnetic spectrum, the higher the frequency, the higher the energy. And that leads to greater kinetic energy when electrons are released as a process. Now, this is the photoelectric effect, which we haven't studied yet, but some of the students were talking about it when we were looking at LEDs, which were emitting light. Photoelectric effect is something where the photons are releasing electrons. Okay, so it's a different part of the course. So don't worry about question 6. Question 7 is the next one we need to look at. Here we have a negative temperature coefficient thermistor connected in series as shown. So this is the negative temperature coefficient thermistor. At first I've written it as RT, but I then changed it to RTH because RT I want to use as R total. So I'm just going to use the blue pen to try and correct my writing. So there's our thermistor, the first resistor, and then the other resistor is just a fixed resistor here, R next to it. So you got one R and the R thermistor, resistance of the thermistor, which will vary depending on the temperature. And then you've got 2 voltmeters and ammeter in series with a cell. The temperature of the thermistor is increased. Well, if the temperature of the thermistor is increased, you know that the resistance will decrease because it's a negative temperature coefficient. That means as the heat goes in, more conduction electrons will move into the conduction band from the valence band where they are normally bound to their atoms. So N, in effect, in the transport equation will increase. Okay? So they want you to say which row of the table shows how the readings on the voltmeter number 1 and voltmeter number 2 will change, yeah, in this situation. So if the thermistor resistor, if the temperature of the thermistor increases, its resistance will decrease. If its resistance will decrease, it will get a smaller share of the voltage, so V1 should go down. So we've seen that V1 will decrease. Well, since the total voltage is constant, that means V2 must increase. Yes? And that's the only one that has increase in it. So we automatically, without looking at this bit, we don't need to look at this bit, we've already got the answer A. Okay? And that's the end of the multiple choice question. So end of section A is 6 multiple choice questions which we could do based on this paper that I put together. So I hope that makes sense to those of you who are looking through this. So there's the multiple choice. The next, so these both came from Unit 2, January 2020. So if you want to look them up later, you can. Yeah. Here's the mark scheme for this section. So we went through question 3, 4, 5 already. And there's question 7. Yes. Let's make sure I got it right. 7 is A. There we go. Decreases, increases. I just didn't circle it. Okay. So your total out of 6. The linear has 8 multiple choice questions. And modular papers have 10 multiple choice questions. They both then have section B, which could be anything. And this one is about core practical 1. So core practical 1 is to find the acceleration of free fall. Okay, and here's the equipment that they used. A ball bearing is held by some mechanism, yeah, and it's released from position A. So obviously at A, the starting velocity will be 0. Okay, the time for the ball bearing to fall a distance L, that's the independent variable, is measured. This was repeated for different decreasing values of L. Obviously the maximum L is the height of the stand, yes, the way they've drawn it, and then they're going to do it for different heights, and they're going to use the equation S equals ut plus half at squared, where u is 0 and a is g, so S equals half gt squared. Maybe I should have written L instead of S. Yes, L equals half gt squared Yes, but I'm explaining that I'm using S as L, okay? And therefore, you can see if you put S on the y-axis, so if you put S on the y-axis, and you put, let's see, what color can I use? If I use t squared on the x-axis, the intercept should be 0. So the intercept C should be 0. I don't know why it makes it into an arrow. The intercept should be 0. And the gradient will be what's in front of t squared. So the gradient will be equal to half g. And this in A level is what they want you to have the skills mathematically to work out what you should put on which axis to get something from a straight line going through the origin in this case. And you should get a yellow line, like my yellow line, directly proportional. S is directly proportional to t squared. It's not directly proportional to t, okay? So you've got to always make sure you can get something that you can determine the gradient for. It says explain how measurements obtained can be used, as I've just explained the theory, to determine a value for g in meters per second squared graphically. They always want you to do it graphically. Your answer should include a sketch on the axis below of the graph that the student would expect to obtain. Okay? So if he did S against t, it will be a curve. Okay? And then he wouldn't be able to work out g from the curve. But if he does S against t squared, yes, as I've explained in the theory above, you can see that the gradient will be equal to half of g. Okay? So what he's got to do to get the data, yeah, he says your answer should include a sketch, but you've got to explain how the measurements obtained from varying L, yeah, remember L is equal to S, how by varying L, what he needs to do. By varying L, which is the height, and using S equals ut plus half at squared, remember to say that u is 0, as I've explained above, it should lead to a straight line through the origin, which means a directly proportional line, okay? So that's the second mark. And if you plot S against t squared, because S equals L, I'm just making sure I've made that crystal clear. I don't leave anything to the imagination of the examiner. S must be measured usually in centimeters to the resolution of your instrument, which will be to the nearest millimeter. But you then need to record it in meters, so you get the answer in meters per second squared when you do the gradient. And time should be measured in seconds, because you want both units to be the accepted SI units for their quantities. And then you just clarify what I explained to you already or in the audio. The gradient of this graph should be equal to half g, yes, and you will need to calculate the gradient from the line of best fit, okay? So don't miss anything out. So, and I would then here put the last bullet point. I would actually show that there, okay? I would show what I have done in this section here. Hope that makes sense. That's how you know that the gradient is equal to half g. Okay, so there's a short question answered. That one is also from Unit 1, January 2020, and it's a core practical one, and there's the mark scheme. Okay, so I'm going to stop there. That's part 1 done. We're kind of halfway through, and then it'll allow me to upload it, and then I'll have a break, and I'll do part 2 in the next hour or so. Okay, thanks for watching. If you are new to my channel, make sure you subscribe so you see when you'll get a notification when a new video is uploaded. I also have membership where you'll get the most recent solutions before anyone else, and that costs a bit of money, and it just helps to pay for the time it takes to make all these videos. But you do not have to, because eventually all those papers will be released, but it may be very close to your exam date. Okay, so thanks for watching once again, and don't forget to, if you know anyone else who's doing either the IAL or the Edexcel linear, to share this video with them so that it will help them prepare for their exams as well. Thanks for watching. Bye for now.